In this video, we will learn everything about body-centered cubic unit cell. So, let's draw the structure first. Now look, where are the atoms? The atoms are present in all 8 corners and in the body-centered. So, this is the representation of body-centered cubic unit cell. This means the 8 corners are occupied and the center, which you can't see from this side, the center, that means the middle of the body diagonal, is also occupied by a ion or atom. Now let's calculate the number of atoms. So the number of atoms will be 1/8 into 8 plus 1, because these atoms contribute 1/8 to this unit cell, and this atom is totally of its own. So this atom will totally contribute to this unit cell. So the total number of atoms is 2. Now the next point is Z slicing. That means you are taking some planes along z equals to 0, z equals to 1, z equals to half, because in case of this body-centered cubic unit cell, you will get atom in z equals to half. Now see, this is at z equals to 0. Where are the atoms? The atoms are occupying the corners. So this is for z equals to 0. Similarly, for z equals to 1, the image will be the same. And in case of z equals to half, that means this plane, this plane, this plane. This plane contains one atom at the middle. So in the case of z equals to half, the atom will be here. This is the Z slicing. Now the next point is projection. Projection in XY plane. That means you are just putting light over the cube. So now where will be the atoms? Here will be atoms at z equals to 0 and 1, 0 and 1, 0 and 1. Now, in case of body-centered cubic unit cell, you will get this atom at z equals to half. So this is the projection in xy plane where you are getting 4 corners at 0 and 1, z equals to 0 and 1, and in the middle you will get atom at z equals to half. So this will be the projection in xy plane. Now come to the packing fraction. So in case of this, you have to again consider the structure. See this. This is your body diagonal, okay? Let me draw this. This is your body diagonal, and this contains atom here, here, and at the middle. So there are 3 atoms, and the thing is, in case of body-centered cubic unit cell, the relation is the body diagonal, which is a root 3, is equals to 4r. How is this happening? Let's look. This one is r, this one is r, and this one is 2r. Now these atoms are in touch with each other. This is r, this gives 2r, and this gives r. So the total body diagonal, which is equals to a root 3, this become equals to 4r. So the packing fraction will be volume occupied by total volume. So this will give 4/3 by r cube into 2, because the unit cell contains 2 atoms. That's why we are multiplying 2 here, and by divided by the total volume, which is a cube. And now from this relation we can determine the value of a, which will come out 4/√3r. So we will just put that value here, and ultimately we will get, you can do the calculation, ultimately we will get this pi√3/8, and this will come out as 0.68. So the packing fraction, which is determined in percentage, will be 68%. So this is all for body-centered unit cell. In the next video, we will see everything about face-centered cubic unit cell. Thank you for watching.